Hey, hello. Welcome to Algebra 2. We're in Chapter 7, Section 6. This is page 4. This is the final page of these notes, and we're in for a good time. We have example 6, which is so awesome that I can't fit it all in one screen. We have this logarithmic equation, and you might say, oh yeah, I got this. Not maybe, but there's something interesting going on here because there's two separate log pieces on the left side of the equal sign. So the first step is to remember this means it's the same as one logarithm with everything multiplied together. Now that we've done that, we're ready to move. Now, of course, I'd like to remind you that this little log really means log base 10. And that's important because they talk about exponentiating each side. I have no idea what that means. So, actually I do. It's just silly. It's the same as saying 10 squared equals 5x times x minus 1. Boom! Exponential form. The variable was in the log, which meant the log was your problem. Rewrite the equation without the log. Okay, so I'm going to rewrite this. This is 5x squared minus 5x, and then 10 squared is 100, and I'm ignoring the instruction there. Well, that's okay, but it's not great. Okay, now, we in fact already did the distributive property. That's fine. Write in standard form. Oh, that's valuable. So 5x squared minus 5x minus 100 equals 0. Well, that's good. But we can do better because we can divide by 5. And that helps bring down the numbers and makes it slightly less insane. So x squared minus x minus 20 equals 0. And that's, that's better. Factoring, because we have this quadratic. You could use the quadratic formula. In a case like this, it's just faster to factor. Ooh, faster to factor. I like that. All right. Well, if we can factor it into x minus 5 and x plus 4, we know that x equals 5 or x equals negative 4. Boom. So those are our proposed answers. Let's see. Boom, we got to do the check. Oh, look, they even told us what the answers were. What are you going to do? Okay, so log 5 times 5, because we think that's what it is, equals log 5 minus 1. And then there's that little question mark, maybe equal to 2. We'll see. 5 times 5 is 25. And 5 minus 1 is 4. And then remember that the property for logarithm says if it's two separate logs added together, that's the same as one log multiplied. Still strange. And then this is log base 10. So that really is 2. So yep, it works. And happiness. But not really happiness about 2 equaling 2. The happiness is that x equals 5 is actually an answer. All right, let's go back to try negative 4. So 5 times negative 4, and then we have negative 4 minus 1. And then 5 times negative 4 is negative 20. Negative 4 minus 1 is negative 5. And here it fails because you have a negative thing inside the logarithm. Not because a little piece of number is negative, but because the whole chunk inside the logarithm is negative. Because negative 20, it says and negative 5 is not defined. But of course, just one of these breaking would break negative 4 from being a solution. So negative 4 is sadness. You're not allowed to have a negative number inside a logarithm. Boo-hoo. Okay. That's example 6. Now we go to the checkpoint, and I'll be straight honest with you. It is insane. I dismissively said it was adorable that they thought the checkpoints could be fit in the boxes last time. It's insane here. So I'm going to really suggest you get out a separate sheet of paper and do it. I'm not going to demand it, but it's unlikely you're going to be able to have a successful experience trying to fit that stuff in these boxes. But do give yourself a chance. Try these on your own, either one at a time or all at once. And, I'll pause in between each one to give you a chance to pause the video. And then I'll still be here when you get back to check. Hey, welcome back. This is number 5, and you can see that the answer is x equals 6. And then I also did a check below it because you really want to check every one of these logarithm problems. The truth is something like number 5, where the bases already match and you're just not even doing anything that's actually logarithmy, you don't actually have to check. It won't matter. But something else where it does, well, could be bad news. So please do check them yourself. Okay, give you a few seconds to pause and make sure you've tried number 6 also. Welcome back. This is the solution for number 6. We're showing that the answer actually is x equals 9. Let's work our way through here. Now, first of all, it comes in logarithm form, but the x is inside the logarithm. That means the logarithm is your problem. Trade it for the exponential version. Get rid of the logarithm by trading for the exponential version. Boom. 3 to the third equals 2x plus 9. 3 to the third is really 27. Subtract the 9, divide by 2, x equals 9. Do bother to check it, please. Again, not checking is just a path of doom and great sadness throughout your life, or at least algebra 2. So please do check them. And when you've finished with this, go ahead and try number 7 if you haven't already. Okay, welcome back. Here we have number 7, very similar to number 6. You had a logarithm, but the exponent, you had a logarithm, but the variable you want, the x, is inside the logarithm. You've got to switch that bad boy out for the exponential version. So 4 to the 5th equals 10x plus 624. 4 to the 5th is 1024. Boom. Subtract the 624. You have 400 equals 10x. Divide by 10, x equals 40. Perhaps. Really recommend the check. Take that 40, stick it in to the logarithmic equation. So log base 4 of 10 times 40 plus 624 is perhaps 5. When you do it, I want to highlight this last bit of the check because you might get to this part here that I'm circling in green. Log base 4 of 1024, and you might say, I don't know if that's 5. I don't really know. Now, if you're super observant from above, you notice that it is 5 because you did 4 to the 5th to get to 1024. But, you might be having an off moment. So, remember, even if the base is weird, you always can change the base. I used ln, natural log, because it's, well, easier, faster to write. But you could use common log instead. Change the base, and you can see it really is 5. Works out beautifully. Okay, let's go ahead and make sure you've gotten a chance to do number 8. I'll still be here when you're done. Welcome back. Here's number 8. What we found is that x equals 12 is an answer, and x equals negative 3 is sadly not an answer, even though it seems like maybe it should be. So let's review the process really fast and be done with this. We have log base 6 x minus 9 plus log base 6 of x equals 2. Property says separate logs being added is the same as one log where they're multiplied. So it's x times x minus 9 inside of one log. Then notice that your problem is, of course, inside the logs. So change it to exponential form. 6 squared equals x times x minus 9. Play around with it a little bit. Distribute. Move the 36 over and factor. You get 12 and negative 3. Do the check. 12 will turn out to be just dandy and happiness. Negative 3 is no good because you end up with log base 6 of negative 12. You also end up with log base 6 of negative. You may not have negative things in your logs. You may not have log of a negative number. Boom. Full stop. So, negative 3 is extraneous. 12 is the answer. And that is the end of this checkpoint. That is the end of this page. That is the end of this section. And that is the end of this chapter. Thank you for watching.